So next is resistance thermometer. So resistance thermometer. Usually this is referred as a resistance temperature detector also, which is called as resistance temperature detector RTD. So this helps us to detect the temperature for a resistance. The electrical temperature, the electrical resistance with temperature for the metallic materials can be represented with a formula called RT is equals to R naught into 1 plus alpha T plus beta T square plus so on plus omega T power n, where R naught is the resistance of the reference temperature, usually where we are having this icing point. R2 is the resistance at a temperature T, and alpha is the temperature of the coefficient, and beta gamma are also the coefficients determined on the other resistances. Okay, so therefore we can easily say RT is equals to R naught into 1 plus alpha T when we are neglecting other smaller values. Generally this can't generate its own voltage, so as voltage source is required for this thing to measure the voltage. So usually Wheatstone bridge is one of the method we use to know the value of this resistance. Okay, so what do you mean by platinum? What do you mean by platinum resistance thermometer? So resistance thermometer, and there is also called as platinum resistance thermometer. So usually, as I said, when we are having this resistance value, we can take minute values, but when we neglect minute values, this is our regular equation, right? So at the same way now, let us consider for type of ranges. So let me take an equation called RT is equals to R naught into 1 plus alpha T plus beta also I am considering. So here this is the regular resistance of the temperature, and this is the at the temperature T what is the resistance, and we are having a pure constants of alpha and beta, which is given as alpha is equals to 0.037 and beta is equals to 0.00000057. So if the temperature is very small, see, as the system goes on, temperature for particular resistance will be very less. So when it goes on, it's not mandatory to take this. So we can go for a fundamental constant. That's why we are writing the equation as RT is equals to R naught into 1 plus KT. Okay, so if I am talking about resistance from R0 to R100, then I can write the equation as R100 is equals to R0 into 1 plus 100K. Therefore, K is equals to R100 minus R0 by R100. Sorry, R100 minus R0 by 100 R0. So if you can neglect minute values and take a constant equation, if you are having a temperature 0 to 100 degrees centigrade, then you can use this formula. If it is 1000 degrees centigrade, you will write it as R1000 minus R0 like that. So at each and every temperature, you will calculate the resistance maybe by using what we call this Wheatstone bridge method or whatever it is. You will know the resistance by using other methods, and you will substitute that resistance here depending on the temperature value. Means at 100 degrees what is the resistance, at 0 degrees what is the resistance, at 1000 degrees what is the resistance. Like that you will calculate and you will substitute and you will use that. Okay, so that is how you can calculate. General example how to calculate. So how to construct this circuit? So usually this is consisting of platinum wire, which is having a free spiral, and the wire should be smooth and free from defects. The resistance wire is generally enclosed in protective tube made of glass, quartz and stainless steel. So I am going to construct a circuit like this. This is the galvanometer. And this is the variable resistance. Okay, so this way I am going to, this is the resistance coil. Okay, so to this resistance coil I want to know the value of this resistance. So this is how I keep a Wheatstone bridge, right? This is PQR and this let it be S. So these are the compensating leads and this is the thermometer. So this is our thermometer tube. So this is how we are going to do the construction, so that any change in temperature can be calculated by using the resistance value. So now the resistance, now the temperature is showing 100. When the temperature is 100, you will connect the circuit like this to this resistor and you will know what is the resistor value. Now when the temperature is 1000, again you will construct the circuit here and you will know the value. Like that, for each and every resistor, wherever you want to know at particular temperatures, you can use this formula. So by using this formula, you can find the unknown value of the resistor. As I said, there is a big circuit. In that big circuit, small resistor has changed its value. Now you want to know. So you will do this construction. You will get the value. Usually P by Q is equals to R by S also you can do. But when you are using electrical quantities, but here we are talking about temperature, so it means here we should use a transducer. So same as Wheatstone bridge you will do, but the formula you should use is this. Clear? So that is how a platinum resistor thermometer equations are considered and changed and got the final equation and the construction. This is platinum resistance thermometer.